Hi guys, welcome back. This is Miss Dieguez. Today we're going to go ahead and do the area and perimeter of regular polygons. So a regular polygon is a polygon in which all of its sides are the exact same length. So all of these lengths here, all of these sides have the same length, meaning that if this one's 3, this one's 3, that one is 3, and these two remaining ones are also 3. So to find the area of a polygon, we have the formula here, which says the area equals apothem times perimeter divided by 2. So the apothem is going to be the distance from the center of the figure down to one of its sides, okay? So it has to go from the center to the side, so over here to one of the flat lines. The perimeter is going to be the distance all around the figure. So all of this, the purple. But before I can talk about the area or about how to use the formula, I want to talk about central angles on a regular polygon. So since it's a regular polygon, I'm going to go ahead and I'm going to draw 5 congruent triangles. So since they are congruent triangles, it means that their measures are going to be the same. I want to find out what the measurement for the angle here is, so this central angle. I do know that if I go around in a circle, it measures 360 degrees, right? And I also know that here I am dividing that in 5 different triangles. So hey, if I go all around, it's 360 and I have 5 triangles in there. So if I do 360 divided by 5, that should give me that measure there, right? So if I do that, I end up with 72. We actually have a formula for that. That formula is going to be 360 divided by n, which is the number of triangles or the number of sides, the same thing. So I use the formula 360 over 5, which gives me 72. I'm going to go ahead and I'm going to give you one example to try on your own. It is very important that you are able to figure out that central angle there in the middle. So I'm going to go ahead and have you guys pause the video, try it on your own. And once you're ready, you can go ahead and return to the video. So you should have gotten 60 degrees for each of the triangles. You should have been able to create 6 triangles and should have done 360 over 6, which gives you 60 degrees. Now, why is this important? Well, sometimes we're going to need to use this to figure out what the apothem is. Okay, so we're going to go ahead and move on to an actual example. And on this example, I'm going to want to find the area of the regular polygon with sides 6. So if I recall, my formula says, hey, the area is the apothem times the perimeter, all divided by 2. So I can easily find out the perimeter. The perimeter is just all around. Since it's a regular polygon, if this is 6, that's 6, 6, 6, and 6, which if I add all of those together, it gives me the perimeter, which is 30. Or I can just say, hey, 6 times 5, because there's 5 sides, 6 times 5 is 30, right? But the apothem, well, that's a little bit more complicated. So I'm gonna go ahead and begin by dividing my pentagon into the 5 triangles. Okay, so if I divide it into the 5 triangles, then I can say, hey, 360 divided by 5 gives me 72. And so since I have 72 there, now I know an angle to the triangle and I also know a side. That's a little bit more than what I knew before. And that's going to be helpful. I'm going to look at that green triangle there. Okay, and so it is going to be an isosceles triangle. And if I draw the apothem, It just happens that it slices that isosceles triangle in half, right in the middle. So if this was 6 before, now I'm gonna have 3 and 3. And the angle here at the top was 72. I sliced it in half, so 36 and 36. Now, why is that helpful? Well, I'm gonna go ahead and just look at 1/2 there. So that little triangle there. I am looking for the apothem, right? So I'm looking for this length here. Now I know that I can use, since I have an angle and a side, I can use trigonometry. You can use SOHCAHTOA, or you can use the law of sines. I'm gonna use the law of sines since most of my students prefer using the law of sines. I do know that this is a right triangle, which means that 90 plus 36 plus 54 equals 180. We could have said, hey, 36 plus 90, subtract from 180, and that gives you 54. So what I'm gonna do is I'm gonna substitute everything into my formula. Sine of 36 over 3, so we're using the side that is opposite or across from it, equals sine of 54 over what's across from it, x. So we cross multiply, and when we cross multiply, we get x times sine of 36 equals 3 times sine of 54. I want to isolate the x, so I have to get rid of the sine of 36. Since I'm multiplying, I know that I'm going to have to divide by the sine of 36. On the left side, sine of 36 cancels out. On the right side, I end up with 3 times sine of 54 divided by sine of 36. So we end up with x equals 4.1291. And what that means is that my apothem measures 4.1291. So now I have the apothem and I have the perimeter. My apothem, again, it is 4.1291. So this is the apothem, 4.191, the distance here. And I have the perimeter, which we said was 30. So I go ahead and I substitute everything in. So apothem times perimeter divide by 2. When you put this on the calculator, it should give you 61.9372, which means that the area for this regular polygon with sides 6 gives you 61.9372 units squared. If you have any questions, please feel free to contact me via email, or you can text me, or you can comment on the section for the homework. Another thing before I go, sometimes you're gonna be given the apothem and you're not gonna know the measure here. So if you don't know the measure here, but you know the apothem, you can repeat the same process. The only thing that is going to change is that the x is not going to be here. The x might be here. Or also, once you figure out that this is 3, you would have had to multiply it times 2 because there's 2 triangles there to get the perimeter. Okay, so it's going to be the same process, just your unknown is going to be different. Again, if you have any questions, please feel free to contact me. Have a good day.